All right, so for today's presentation, we wanted to give you a quick introduction to ON Semiconductor's KNX twisted pair transceiver product family. We want to highlight our previously released devices as well as the most recent additions to our product family and go through those in detail. For today's agenda, I want to cover the following topics. First, we'll go through our KNX transceiver family snapshot, discuss the devices in detail, what they do and what features they have, cover them, also review the BOM comparison and how they differ and some of the advantages and disadvantages of both. I'll also share with you what KNX collaterals and supporting tools we have. And then finally, just give some rough takeaways and summarize what we have to offer. So this first slide is our standard product line card that kind of highlights some of the key features and benefits of the devices. They also mention the typical markets and applications that these devices can be used for, as well as ordering information and links to more information online. It's a very good slide to get access at a high level summary of what our parts can do and what they have to offer. So to get started, ON Semiconductor initially released the NCN 5120 device back in November 2012, and it was our first KNX certified transceiver. It was a Phi plus Mac device, and it was one that performed well. It met the KNX certification and did everything that it needed to do. But we made a decision to release an updated family that had additional features and some improvements to the devices as well. And those are the NCN 5110, 5121, and 5130 devices. The NCN 5121 is a pin-to-pin compatible device with the previous 5120 with improved features and the same bill of materials. The NCN 5130 is a full feature device with additional features and performance improvements. And the NCN 5110 is a Phi only device where it acts as a bit transceiver and the MAC layer has been pushed to the microcontroller in the KNX application and product. So slide 5, this one it kind of goes through and highlights some of the differences between the devices. And so basically, if we go through each of these items here, as was previously mentioned, we released the NCN 5121, NCN 5110, and NCN 5130 to improve the efficiency from what we had of the 5120. On top of that, the 5120 and the 5121 can supply 10 to 20 milliamps of bus current consumption, whereas the 5110 and the 5130 can supply up to 40 milliamps of bus current consumption. Another advantage of the newer devices is that they have a current limit that's been added, and so that's a nice benefit that's been added to these devices. The 21, the 20, the 21, and the 30 are 5 plus Mac layer, and then the 110 is the physical layer only. And then all of the devices have a 3.3 volt fixed DC-DC and an adjustable DC-DC and a 20 volt LDO. And then one of the nice features about the 5130 and the 5121 is they also have some monitoring capabilities to track and make sure that the KNX device is in correct operation and working correctly. Some of the other key features. So we mentioned that there's 3 embedded highly efficient power supplies, the fixed 3.3 volt DC-DC. One of the new features of the programmable DC-DC is that it can go from 3.3 to 21 volt. And then we have the 20-volt linear regulator. There's also the ability to configure the current up to 4 virtual nodes. All of our devices are capable of a 9600 baud on the KNX bus, and include the embedded PHY and MAC layers as mentioned before. On the newer parts, there's the ability to have a selectable KNX bus current slope, and that's through the fan-in pin. We'll talk about that in more detail. And then also the ability to do the supervision of the KNX bus voltage. We also have the ability to select either UART or SPI interface that can be used, buffering of sent data frames, and the optional auto acknowledge. And then also there's the ability to make it an analog transceiver only mode, which is what the 5110 enables. Also on their newer devices, we've extended the temperature range from -40 degrees C to 105 degrees C, which gives you a higher level of reliability and quality in the device. And then all 4 of our devices are available in a QSN40 6x6 package. Moving on to the next slide. Here's a block diagram of one of our typical devices. And what we wanted to do was highlight some of the differences between our previously existing device, the 5120, and the newer devices, the 51110, 21, and 30. So if we start up in the upper left-hand corner, one of the biggest changes was we improved the efficiency of the KNX bus by redesigning the bus coupler. And so we made a change there to make sure that we were optimizing the bus as efficiently as we could. Also on the 110, 21, and 30, we added the fan-in control, which allows you to control the slope of the KNX bus, as well as the loading. And then there was a wake-up feature on the 5120, which is not included on the 110 or the 21 or 30. Also, the oscillator on the newer parts is controlled by a pin, and on the previous version it was controlled by a register. And then as we mentioned, the analog buffer feature was added to the 5121 and the 30, which allows you to track different performance characteristics of your KNX device. So you can track the KNX bus voltage, the filtered voltage, the bus current. You can track the DC-DC converters, or the 20-volt supply, or the temperature. And that allows you to check the status of your current KNX device to see how it's operating. And these features are not available on the 10 device, the PHY device only. And we also made some slight changes to the 5110, 21, and 30 into the DC-DC converter. And so it's just basically the formula that you use to calculate the DC voltage has been changed. Also, as mentioned on the 5110 device, the digital block is not included and not available. So here, let's go into a little bit more detail and a straight comparison of the different devices. So as mentioned, the 5120 is a pin-for-pin compatible device with the 5121. The 5110 is the analog-only bit transceiver, and then the 5130 is our full-feature device. The 5120 can supply up to 2 discrete models, 10 or 20 milliamps, and that's the same with the 21. The 110 and 5130 can also do 10 or 20 milliamps, but on top of that, they also have the ability to supply 5 to 40 milliamps. On the 5120, there is no current limit, and we've added a current limit on our other 3 new devices. On the 5120, the bus current or bus coupler voltage drop was quite a bit larger than on our newer devices, and that's what we did to really improve the efficiency and bring that down. And so you can see that on the 21, it has a much higher efficiency, and then if you go to the higher current on the 110 and the 130, that it also has a decent drop that's much smaller than the previous device. So with 50% communication on the bus, we also see an improvement in the bus current consumption. And even when there's no communication on the bus, you still see a significant improvement from the previous devices. As mentioned before, there's a 3.3 volt fixed and a 3.3 volt to 21 volt adjustable DC-DC on the 5120. On the newer devices, it's the same, but we also have the ability to go down to 1.2 volts for the adjustable DC-DC converter. Also, there's the 20 volt LDO output current, so that was limited to 4 milliamps on the 5120. On the 5121, that can be up to 20 milliamps. And then on the 5130 and 110, that's up to 40 milliamps. So quite a bit more current output current on your 20 volt low dropout regulator. On the ability to control the DC-DC voltages and then also the LDO, that can be configured by a register on the 20, 21, and 30. On the 110, that's not available, and you have to control it by signals coming from the microcontroller. And also mentioned, there's the analog signal monitoring feature. You can track these different voltages and currents and temperature on the 21 and the 30, but that is not available on the 110 or the 120. And then also the temperature range on the newer devices has been extended. Instead of minus 25 degrees C to 85 degrees C, we've widened the temperature range to be minus 40 to 105 degrees C. If you're going to update your designs from the 5120 up to the 5121 or 30, these are the areas that will need to be adjusted. So the first is the bus capacitor is a bigger capacitor, and that will need to be changed. The KNX bit transmit resistor is also slightly adjusted. Also, you have the ability to add or leave floating the fan in pin, and that is what helps you control the slope of the KNX bus. And then also the DC-DC, the formula to adjust the DC voltage and the ratio of resistor R4 and R5 has changed, and so that will also need to be slightly adjusted. So this kind of shows you a typical BOM for a KNX application, and the lines highlighted in red show what needs to be changed from the previous part to the newer one. So the first line, C2, on the 5120, typically we use a 4.7 nanofarad capacitor on the KNX bus for the energy conservation capacitor, and we've moved that to 220 nanofarad. And that's one of the key features for improving the efficiency of the device. Also, the shunt resistor for transmitting on the 5120 was 22 ohms, and that has now been updated to be 27 ohms. On the DC-DC, the adjustable DC-DC, the formula has changed, but you still use roughly close to the same size resistors. And for the fan-in resistor, that was not needed on the 5120. You can leave that floating, or you can adjust the KNX bus slope by adjusting the resistor between these values, 10K to 93K. And the formula for that is available in our application notes and data sheets. Speaking of application notes and data sheets, ON Semiconductor has a large online suite of tools available to help you with your design in. That includes evaluation boards. And everything is available at the link above for our NCN 5130 device. But we also have evaluation boards available that will let you quickly test your KNX product with our transceiver to make sure that it works as expected. We also include bill of materials and schematic and layout. And also we have an evaluation board, a user's manual that allows you to quickly get up and running and start using the device. We have some online tools that help you look at efficiency and a BOM calculator to estimate cost and number of components needed and values to use. And then we also have application notes. So one application note details how to achieve or go through the KNX certification procedure. We also have a note on porting the 5120 to the 5110, 21, and 31. And then we also have a selection guide for how to use the DC-DC converter and set up the different components there. We also offer certified stacks through our partners, certified software stacks through our partners, Swine-Searle and TAPCO. So some of the key takeaways from today's presentation. So ON Semiconductor has an extensive family of KNX twisted pair transceivers, and we've invested heavily in this market, and we expect to continue to do so in the near future. All devices are KNX certified and launched today. And so the nice thing is that because we have that KNX certification, it allows for a streamlined integration into the end product, the end KNX application product. We released a couple years ago our newer devices that have additional features and improvements. And we have an extensive set of collaterals and supporting tools online that will help the end user get designed in quicker and achieve a high performance in their device. Part of that is we have a flexible power supply scheme, so 2 DC-DC converters with an LDO. We also have the streamlined solution, so low BOM count, high efficiency, high drive capability, extended temperature range, and then also the customer-friendly features that aren't required by KNX, but allow you to build in a nicer, higher-end product. So we also offer application engineering support. If you have any questions, feel free to contact myself. I'm the product marketing manager for KNX. My name's Riley Beck. And then also Peter Cox is our application engineering manager, and he's available for questions as well. And that's the end of our presentation today. Thank you for your time.